All right. Well, thank you very much, everyone, for being here. What I'm going to try and I've got a bunch of questions that I'm going to ask the panel for the first 20 minutes or so. Then I'll be over to you for questions. And I think my preference always is to not do long introductions for the panelists, but ask questions which, in the first answer you give, you just tell us a little bit about yourself, hopefully. I've hopefully selected questions that allow you to do that. Vittorio, I think you're over in the States, so I hope you can hear us. Can you hear us? Give us a smile and a thumbs up if you can hear us. Fantastic. Excellent. All right. So this panel is all about successful models for public-private partnerships in the fusion industry, focusing on how they can all drive innovation, reduce risks, and also, most importantly, attract investment. So, Heike, I'm going to start with you, since you're at that end of the room. You're the Chief Operating Officer of Marvel Fusion. So can you just talk to me a bit about what Marvel Fusion does, but also what is the shift like between pure R&D, which is what fusion has been like for a long time, that's just pure scientific R&D, that's what all it is, to the C word, commercialization. This is a moment where that's sort of happening. So tell us about that.
Yeah, happy to. Oh, do I need to put that up a bit?
Can you hear me? We can hear you.
Perfect. So as you said, my name is Heike Freund. I'm the COO of Marvel Fusion. At Marvel Fusion, we are pursuing a laser-based approach to fusion energy, so utilizing very short pulse lasers with high intensities to ignite a fuel. Our company is based in Munich, Germany, but we also have operations in the US, in Colorado. Actually, we are building a facility in a public-private partnership, so happy to talk more about that afterwards. We are a company of 70 people currently. To your question, like what is it like to move now from R&D to commercialization? So I think what we are seeing in the fusion industry right now, and I think it's amazing to see that, is that companies are starting to build real things now. So we are starting to, whether that's Commonwealth Fusion that is building Spark right now, whether that is us that are building a laser facility in Colorado right now, but it's like real facilities that are being built right now. And I think this is so important for the broader ecosystem, because to build something, you also need suppliers that deliver laser components, that build concrete buildings and so on. So it's really an opportunity now where like the broader ecosystem becomes involved in fusion. And it's not only the fusion companies themselves doing R&D. So I think that is important. And I think the other thing that is important is now to also, like when we talk about commercialization, think about potential off-takers of fusion energy and involving those potential customers also early on in the journey. And I think those are the things that we are seeing right now. And if I look at this conference and the attendees of this conference, I think it's also very well reflected that this is not only a science conference, but also people along the value chain and potential off-takers that are actually participating here.
Well, you've preempted my question, next question, which is going to be, you've talked about the different types of people involved. Just give us a set of flavor of that. How complex a task is it that you're doing? How many different types of experts do you need to have involved in your company and sort of the ancillary around to sort of make this thing happen?
Yeah. So, I mean, I just mentioned we are a team of 70 people, right? And with a team of 70 people, you can't do everything in-house, right? So like building a fusion power plant at the end is a team sport, and you need to involve many different parties. And some examples of who are we involving. On the one side, we work with Siemens Energy on our power plant technology. So we work with a full team at Siemens Energy, working on our pre-conceptual design, working on the whole plant layout and everything. And I think that is a real benefit of like pulling partners in, because otherwise I would need to hire hundreds of power plant engineers right now in my company. And I think developing the next generation of turbines is a very different task than developing a fusion concept. So I think as a startup or as a company, focus is one of your core aspects that you always need to consider. So like finding partners to work on topics that are not in your core focus area is super important. So Siemens Energy is one example, but I think another example is also Colorado State University, the university with whom we are building our facility in the US right now. And we are building a laser facility jointly with the university. It will belong to the university after a certain period of time. And I think that's also important, because if we look at, there is more than 45 different fusion companies out there right now. if I look at all their roadmaps, all of them have kind of machine number 1, machine number 2, machine number 3, then kind of like prototype of a power plant and power plant. Now, if 45 companies all build 4 different kind of like machines or facilities, we will have a lot of different machines standing around, and who's going to take care of them? So like integrating those within universities so that we have students that can actually go, in our case, to the laser facility also in 5 years from now, learn on these lasers, like work with those lasers, I think is super important. So finding partners also to build out those prototype facilities that we are talking about, I think is super important.
Okay, thank you, Heike. Erik, tell us a bit about Fusion Europe. And one of the things that you guys advocate for is sort of co-development of technologies rather than what traditionally you might call technology transfer. You know, something comes up in a lab and off you go, transfer it to industry. But you're talking about something called co-development. Tell us what that is and how it works in this particular industry.
Okay, I think fusion sector is changing. So we can see this event that is something new for this sector, because usually we are familiar with symposium or technological conferences, but this conference where we are talking from a different perspective of this fusion sector is new because everything is changing. So cooperation, the way that we usually cooperate in this sector until 5 years ago, was, as you mentioned, with this technology transfer, or our main challenge was trying to involve the supply chain as early as possible in the low TRL. So going from technology transfer to co-creation, that was the main challenge. And now, in the last 5 years, we have a totally different framework. We have between 7 and 9 billions in the market from private money. We have a lot of startups trying to develop different approaches for making reactors or making fusion a reality. And this is a real game changing, and the rules are changing, so you need to work in a different way. So I think it's time to improve the collaboration. So that's the main challenge we have now. We have all the technology that has been developed for ITER, all the technology that has been developed for the construction of other facilities, and we have all the new concepts that are in the market. So we need to work together. So that's the objective of Fusion Europe. So that's why this is more important than ever, to have associations or to have platforms where all the different stakeholders could collaborate. That's the idea we have, but it's nothing new. So industrial association is a concept that already exists, that is already working. But in my case, I came from the Spanish Science Industry Association, and we are also founders of Fusion Europe, which is the European Fusion Business Association. And we have 15 years of experience working in big science sector in Spain. And we see that having an industrial association is not enough. So you need to have some other boundary conditions that need to be in order to be really useful for the sector. So in our case, we need to be open. So all the different companies that are part of the market need to feel comfortable inside the association. And that's why Fusion Europe, we started in May last year, so close to 1 year from now, a process in order to do a public consultation with more than 80 inputs from companies and 15 inputs from different stakeholders in order to establish an association which could be a platform for everybody. So that's one of the key elements, and now the association is being established. So next week we expect to go to the notary and have the legal entity. And the main challenge starts now, because establish the association is not enough. Now we need to do real useful activities for our companies, and in order to collaborate between the public and the private sector.
Thank you. Vittorio, I'd like to bring you in from across the Atlantic. Tell us a bit about your work at Oak Ridge. And specifically, what I'm interested in is that there are dozens, hundreds of different technologies that need to be taken from the laboratory into commercialized use so that you could have fusion systems that are useful in the world. Just give me a couple of examples of the ones that you think are most interesting and tractable in terms of getting from the lab to the commercialized sector. Well, what particular technologies are you focused on? Are you thinking about that you think that this room should also be thinking about?
Well, okay. So, I joined Oak Ridge almost 6 years ago. I'm a distinguished scientist. So personally, I've been the PI of 2 ARPA-E awards. So the first one is called the Fermi Fusion Energy Reactor Models Integrator, and was awarded I got it awarded shortly after I joined Oak Ridge, and was about building a digital twin of a blanket. And I don't know if you are familiar with blankets. Is basically the volumes. What is, you have the plasma, the first wall, and then you have these volumes of components around it. And the blanket is a key component, and it has a very low technology readiness level. And that is one of the main technology gaps to go commercial, at least for magnetic fusion confinement machines. So the idea we just completed the project to have a very high fidelity simulations of the blanket to make sure that the designs that are proposed they deliver the engineering parameters that are supposed to deliver. And this is without building one blanket. So to give you an idea to the audience, nobody has ever built a blanket yet. So there are a lot of concepts around. There are, molten salt blankets is Commonwealth, for example. They proposed an immersion liquid blanket. There are solid state breeders blanket. There are lithium, dual coolant lead lithium blanket, for example. But nobody has ever built one, and nobody knows, how good they are, how well they're working, and you don't know that, if you never built anything, you don't know, right? So the first project was to minimize this risk that, hopefully you build one blanket, and with very high fidelity simulations, you build the blanket once and it's working. And then the second ARPA-E we just got awarded. I'm also the PI of this so we patented a new blanket that is supposed to hopefully be better than the current concepts. And the key of this blanket that we patented is that it should allow no lithium-6 enrichment. So to make tritium, so DT fusion, you have to make tritium, right? And tritium doesn't exist in nature, so you have to make it, and you do it through transmutation of lithium and under neutron irradiation. And typically, lithium-6 is the easiest because it has a very, very good transmutation at any energy, also very low energies. The problem is that, again, this is another technology gap. Lithium enrichment in the West on on scale, so larger lithium enrichment facilities do not exist anymore. So everybody, pretty much is assured right now that any company will need lithium-6, and there is not enough lithium-6, and we don't have a manufacturing facility that does lithium-6, enough lithium-6. And there was one during the Cold War, but it got called, there was the Colex process, but it was closed in 1963 and was based on mercury, which is very polluting. So who does lithium-6 enrichment on scale? China. Okay, so if you want to buy a lot of lithium-6, you have to go to China. So this is so. Anyway, summarizing, I'm focused a lot on blankets, from modeling and simulation to new concepts.
Well, we'll be talking about the geopolitics of all of this in the next session, so it's worth listening to where we get all these materials and how to make sure the supply chains are secure. Moving on, though, Luca, you work in possibly my favorite place on earth at CERN. It's incredible. It's a wonderful thing. And I've even seen the workshops where they're building superconducting magnets for different fusion plants there. I'm just curious, can you explain to people here what CERN, the Cutting Edge Particle Physics Lab, is, why it's involved in fusion work? What is the contribution that you're making to the people in this room who are trying to build machines that will one day power systems and make money and things?
Mm-hmm. Thanks for the opportunity, by the way. So Luca Bottura, yes, I spent my career around superconducting magnets at CERN since 1995. So CERN, the European Council for Nuclear Research, we don't do anything nuclear, meaning that we don't build power stations. We actually use energy and money, but for a good reason. So excellent science, as you mentioned. It's one of the pillars of our activity. It's not the only one. The second one is educate. So we have about 1,000 between students and PhDs at CERN. We do that in high collaborative spirit. That's the third pillar. And then finally, we produce technology. And that's, I think, the key to the question, because technology we need for these accelerators, extraordinary machines, superconducting magnets, but not only, radio frequency cavities, detectors. It's something that we desperately need for the experiment. We wouldn't be able to run the machines without. And now, in that respect, we are able, we are very resilient to the process of taking low TRL objects from crazy ideas to something that works in an accelerator. We don't do that alone. We do that with industry. Okay, I think that's a bit what's happening in fusion. So some crazy ideas of many years ago now finally is going quickly into industry.
Which crazy idea? Tell me. Give me an example.
The crazy ideas from CERN or for fusion? I meant fusion.
Yeah. Yes, whichever one you like. What do you think, what kinds of things? I know that people at CERN are really pushing the boundaries in every direction, really. But what are one of the crazy ideas that perhaps you think maybe they didn't even think would be useful for this topic, but now is becoming central to what's going on here?
All right. So what we are doing at the moment, we are looking at alternatives and the next steps for accelerators. One of the alternatives we found is a muon collider. Muons, they only live 2 microseconds. So you have to be very quick. It's big electrons, yes, correct. But you can build very compact machines. So they don't need to be very big. They don't need to be very power hungry. And in that respect, we need to develop technologies, in particular HTS magnet technology, that is very similar to what's happening to fusion. And realizing that fusion will also come into CERN to look into our technology, that's why we initiated this Fusion Technology Coordination Unit, to make sure that we talk on the same terms.
I was going to say, if people here have not been to visit CERN just for pure enjoyment purposes, you really should. It's one of the most incredible places in the world, full of amazing people, and also all the sort of future is laid out there. Even if they don't recognize it themselves, it's there, all the technologies. But coming up to you, Erik, just going on from what Luca said, CERN's job is to find out what stuff is made of and how the universe began and all these things. And it's produced huge amounts of economic benefit as a sort of byproduct of whatever it's been doing, right? Yeah. We know that. How do you make sure that, is it important for organizations like yours who need technology, who need frontier ideas, to be looking at CERN all the time and perhaps even trying to work with it to direct what it's doing? I mean, there's an academic freedom issue here as well, which you shouldn't interfere with. But how do you work together with public institutions like this and your private partners as well?
Okay, it's not an easy question. So it's depending on the different facility, the way of working is different. But for sure, what we have is the knowledge in this kind of facility. So we didn't know that the use of a protocol in CERN for interchange information between different facilities in CERN was going to be the origin of the internet we have now. So what we know is that the knowledge is there, but also we need someone who is looking in order to use this knowledge in other applications. So, for example, we have been in a session before talking about HTS magnets as one of the
high temperature conducting magnets. Yes.
Yes. So this could be one of the game-changing again technology in the market, because we still don't know what is the future application of this kind of technology. But for sure, what we need is to know what the scientists are developing and to know how to use it in other markets. So, For that, what we usually only need in many cases is events like this where people could share the knowledge and could share the opportunities. Because it's typical that someone is developing some technology in a basement in somewhere, and if nobody knows about this technology, nobody can use it. So I think the first thing we should do is try to work together.
And know what's happening, first of all. Make sure you're there visiting all the time, make sure what's happening. And Luca, just one quick point I'd like to add from you. Yes, it's really, of course, very good for companies and the industry to know what you're doing. But do you try and set any limits to what they try and in directions that they push you in? Because, of course, you're still an academic institution ultimately.
Mm-hmm. Yes, we are. But as I said, we are organizing ourselves also to support this transfer of transfer of the technologies is actually transfer of knowledge that we are trying to do. In fact, we do collaborate. I mean, we've been collaborating with ITER since 2008. Eurofusion, Fusion for Energy, Gauss Fusion Private. And so, there's a number of channels that we set up. And, from our side, it's only benefit in the sense that we give out, we prove that what we do is not just useful for science, but for society and other science, and we learn. And that's also an added value that gets forgotten sometimes. In doing this type of collaboration and transfer, we do learn because there's questions that come in that are different from what science would ask you.
Heike, can I ask you about how you organize your partnerships? Public, private, everything. You talked about all the different teams, all the different expertises. What have you learned from your work at Marvel in terms of how you organize different teams to make sure that you get the best out of them?
Yeah, I think it's a super important question. And I think if you think about partnerships and strategic partnerships, those have to build and develop over time. Like you can't just say like, oh, on day one, like, hey, let's have a big strategic partnership, but it has to develop over time and trust has to be built up on both sides. And then I think one thing that I've experienced that is super important is then when we set up our teams, that they really work as integrated teams. Because I think at the point where we are at right now, if I go back to the partnership with Siemens Energy, for example, we can't have a customer-supplier relationship where we say, oh, these are all the requirements that we have. Please go and develop a turbine and then come back in 2 years or whatever. You cannot do that in a field that fusion is in right now, where everything is changing so rapidly, right? So how do you manage change management? I think you can't manage change management or it's way harder if you have a classical customer-supplier relationship versus working in an integrated team, having integrated teams that go through that all the time. And I think then it's super important to align on a joint vision, obviously, then have the teams working on these, but also being very open and transparent on both sides that things change over time and that they need to be integrated. And then there's obviously always the big question, how do you handle IP? And I think that is between private companies and public institutions, that is between private companies and industrial partners. And there is no blueprint that you can use for every kind of partnership. But in my experience, it's always good to, obviously you need to address the topic of IP. And then if you can find areas where you can say, that's an area where the IP belongs to the science institution or the private company, that's the part where the IP belongs to the industrial player, and then having maybe one part that is joint IP. But I think those interfaces need to be super clearly defined. Otherwise, you will run into... Beforehand, yes. Obviously, you can discuss them over time if things change, but like having clear areas where that's the IP of partner A, that's the IP of partner B, and then there might be an area of joint IP. But Luca, you had
Just a comment on that, because obviously IP is one of the big topics of discussion when we collaborate, especially with the private sector. Yeah. Now, it's important to realize we also have different roles.
Yeah.
We don't want IP to sell anything. We don't want IP to do any business. The only IP that we need is the one to build and construct and operate our machines. So from that point of view, we did find a balance that allows the business to make a business and we to run the scientific program. So it works.
Yeah. Vittorio, can I ask you also a bit about how technologies go from somewhere like Luca's lab to being used in something like Heike's machines, it doesn't go smoothly, right? These things are never smooth in any industry. And I'd like you to talk to me about the valley of death, this idea of laboratories sort of coming up with things, and then before they can be really used in commercial enterprises, they need to have some development, but then no one's taking that on, and everyone forgets about them and moves on to something else exciting.
Yeah, well, the valley is called the valley of death because nobody wants to invest at that tier.
No one wants to be in there.
Technology,
yeah.
technology readiness level, and why is death? Because it's very high risk. So private companies, they don't want to invest in a very high risk technology that maybe they pour hundreds of millions or billions, or depending on the company, to realize that it's not feasible. You cannot scale it up. You cannot commercialize it. So typically, that's one of the missions of the lab, is to progress technologies up to TRL 6, I would say 5, 6, where the risk is much lower, and then the private sector is willing to invest big money. Now, in the case of fusion, I would say that there is this novelty where the private sector seems keen to invest also on low TRL technologies. And I haven't seen this before. I think, overall, I think, bringing fusion to the commercial market as electric power plants, I think it's similar to the effort that was done in the Apollo project or the Manhattan project. Is a massive undertaking, and so if you want to follow this very aggressive timescale, these companies, they say, oh, we're going to have a commercial power reactors by 2035. I think you need way more funding, and you have to accelerate the R&D, because there are a lot of technologies which are TRL3, for example. So a lot of technologies are in the Death Valley, and you just have to try them all, and that will require a lot of more funding if you want to have an aggressive time schedule.
Thank you, Vittorio. I'm going to ask some questions from the audience now. We've got a few minutes left. If you want to ask a question to any of our panelists, please put your hands up, and we'll get the microphone over to you. Don't be shy. Anyone? Yes, please, here. Anyone else who wants to ask another question as well? Let us know.
Hi.
Please tell us who you are, and if you've got a question for anyone specifically, then do let us know.
All right. I'm Michalis. I work with PhysicsX. We're a company that brings machine learning and AI to physics and engineering applications. And I just wanted to ask, we just heard that you consider this to be a sort of Manhattan or Apollo mission kind of endeavor. Do you think there's fragmentation going on now with all of the different sort of fusion companies pursuing this independently? And do we need to sort of concentrate the efforts or centralize the efforts in order to make this happen, if it is, a Manhattan kind of situation?
Thank you very much. Anyone else got any other quick questions before I take this one? Okay, so the question was, given the scale of the project and the scale of the challenge, as Vittorio says, maybe it's a Manhattan-style project, is the sort of spreading of the technology and the money and things into different projects to try and do it, is that the best way to do it, or some centralization necessary? Maybe, Erik, I can start with you. This is a good question for you because you're representing multiple organizations.
Yep.
And public, private. What do you think about that? Is it really a Manhattan project, and should it be concentrated more?
I don't know. Collaboration is not an easy topic, but I think something we always need in these cases is share a vision. So having the same objective and clarity in order to speak one to each other, and honesty. But those are the main ingredients I think are necessary for that. But how to use in every case is different. But if you have the ingredients, you have a shared vision, you have clarity in your communication, and you have honesty, I think it will be easy.
Does anyone else want to have a quick comment on this, diversity versus concentration? Heike?
So I would say at this point in time, it's actually good for fusion. There are of these 45 plus companies that are out there, I would say not 2 or 3 of them are pursuing exactly the same approach, and that is really pushing innovation right now in the field. So I think right now, my opinion is it's good to have this diversity of approaches. I do believe that over the next 2 to 3 years, we will see some divergence in the amount of companies and the approaches and so on for many reasons. I think there's restraints on like available capital. You won't be able to build 45 different demonstrator power plants and so on. And so there will be some natural convergence on maybe a handful or 2 handful of approaches. But I would say currently it's good for fusion that we have different approaches and that we are really pushing innovation in the field.
Thank you, Heike. And competition is always good, I think. These things, more innovation.
If there's no competition, there's no market.
Luca, very briefly, because we're running out of time.
Yeah, over time. So just to remind everybody that, yes, it is a big Manhattan-style project, but concentration has been going on for the past 50 years or so. And I think also that now is time for a change because there's an urgency in the energy issue. And so having this movement and wave, I think is beneficial. We need an answer. And if this is the best way to get the answer, let's go this way.
Thank you very much. Okay, can I ask you to put your hands together for our panel? Vittorio, Luca, Erik, and Heike. Thank you very much. Thanks a lot.